Okay, 9.1 composition of functions. So we're going to look here at what this means. It's a new concept with those. I think composition means putting things together. And so let's break that down and see what's going on here with these. Some definitions. So our first one, actually our only one, the composition function put this next to it, f of g. So when I write that there, you'll notice this is a little o here. It's not an actual letter O. It's a symbol. It's a smaller circle, open circle there between those. And this is defined as f of g of x equals, okay, make that a better g there, f of g of x equals f of g of x. So notice how we rewrote that as a function inside a function. So we do it in the order, whatever second goes inside the first. So we're doing our g of x inside the f of x there. So we're plugging that in, that function in for those pieces, okay? Where x is in the domain of g and g of x is in the domain of f. Okay. And then we always kind of like, you heard me say it a couple times there, but f of g of x is read as f of g of x, right? For those. And so we need to make sure we're reading that properly there. You'll hear people shortcut that, say fog. We rewrite it with g is first. And order does matter with those pieces. Okay, if I put g of f, then the g goes first and f is plugged into it. Okay, so we got to be careful there. So let's look at our examples. Okay, for f of x equals 3x plus 1 and g of x equals x squared minus 2x minus 6. Okay, so we have those two functions. We want to find the following. Find the following. So number one, what is f of g of negative 1? And we can do numbers. Okay, it's not a problem. We're just plugging that in for x and working through it. Okay, so let's see how to break this down and work through these problems. All right, so the first thing that I'm actually going to do here, so it's a little bit easier to follow, is I'm going to break this down as f of g of negative 1. Okay, so that we can see exactly what we're doing, plugging that into the g, then we're going to take that result, plug it back into f, and see what we have. All right, so f with g of negative 1, that means we're going to plug negative 1 into g. So we're going to get negative 1 squared minus 2 times negative 1 minus 6. Okay. Now we'll do all that math work, simplify that piece. So f of negative 1 squared is 1 minus 2 times negative 1 there. That's going to be plus 2. So we're up to 3. 1 plus 2 is 3. Minus 6 is a negative 3. So now that we've done that math, we've gotten our negative 3 here. We're going to take this and plug it in for our x value there in f. And so we're going to get 3 times negative 3 plus 1 3 times negative 3 is negative 9, plus 1 is negative 8. Okay. So there we have our composition using negative 1. Now we can use anything we want there based on what they give us. They can give us new equations and they'll do that from problem to problem. Here, we're just going to keep using the same equations for a few moments until we kind of get through a lot of different examples for that. But it's all using the same thing, okay? So now I want to do what is g of f of 2. Okay. G of f of 2. All right, so now we need to make sure we put it in the correct order for those. So this is going to give me g of f of 2. So that means we're going to plug into f first and then plug into g afterwards. All right, so we get g of f is 3x plus 1. So we're going to plug 2 in there. So 3 times 2 plus 1. Okay. And so 3 times 2 is 6, plus 1 is 7. So g of 7 now. So in g, we're going to plug in 7. So 7 squared minus 2 times 7 minus 6. And so that's going to give me 49 minus 14 minus 6, which gives us 29 for our final answer there. Okay. All right, number 3, still using the same 2 equations. What is f of 4? Now, it doesn't matter what letters we use. We can see here we're using the same 2 letters. It's fine. We plug into the function and we plug into it a second time for those. So we can do any combination. They could give us 5 different equations and we can pick different ones out of those. So it doesn't really matter there. We follow what it tells us. All right, so we want to do f of 4. All right, so f of 4, we plug in here. So we get 3 times 4 plus 1. 3 times 4 is 12 plus 1 is 13. We take the 13 and plug in to f. So 3 times 13 plus 1. 3 times 13 is 39 plus 1 is 40. So it's all about paying attention to the letters they give you, what we're plugging in where. Right? F of g of x. Now, what if we start doing some letters? Okay, what if I tell you to plug in a letter? Now, the good thing is we used x there, so that doesn't really change a whole lot. So here we're going to do f of g of x. Well, we know g of x. G of x is already down there, so that is f of x squared minus 2x minus 6. Okay, so we can plug that in, we can work that out. All right, so now we're going to take this, plug it into f, and we're going to do 3x squared minus 2x minus 6 plus 1. So we took all of this and plugged it in right here into that x to be able to work through that. Okay. Well, now we need to simplify. So we're going to distribute, combine any like terms, do all of those things here. Okay. So we distribute in, we're going to get 3x squared minus 6x minus 18 plus 1. And then we can combine those here. We get 3x squared minus 6x minus 17. And there's nothing else to do. So that is our results. Okay. Now, make sure you're following order of operations. There are going to be times that you may have a square out here, different things like that. Pay attention to those details. It's all about using all of our previous stuff to combine these pieces together. Okay? All right, so when you do one more problem, we'll be done here today. It's going to look a little bit different though. And so let's just kind of, I need the whole board for it. It's kind of a big problem because there's multiple things to do. So let's do that. Actually, I need this. So it says find f of g of x and g of f of x, then find the domain of each. Okay. All right, so let's look at our equations. So f of x equals the square root of x plus 5, and g of x equals x squared minus 5. Okay. All right, so we need to do both of these. So let's start with our f of g. So f of g of x. So just like we did before, we're going to do f of g of x. So that's f of x squared minus 5, just here. And so that means we're going to take x squared minus 5 and plug in. So x squared minus 5 plus 5, and we're going to take the square root of all of that. Okay. All right, so here, those are going to cancel. That leaves me with the square root of x squared. But we do have to remember, because we don't know anything about x squared right now, that when we take the square root and it's an even power, that this gives us the absolute value of x. Okay, so we have to remember that from way back in unit 3. Okay, and that is our f of g of x. Okay. Now we'll talk about domain about that in a minute. But let's go ahead and find our g of f. Okay, so I'm going to do that over here. G of f of x. And work through that. Okay. All right, so that means we have g f of x. So g of square root of x plus 5. Okay. So that's what our f is. So that means now we're going to plug that in. So we're going to get square root of x plus 5 squared minus 5. Now, because that square is on the outside, when we go and square that square root, we don't need the absolute value because we're going to already know some things about our x here. So those are just going to go to x plus 5 minus 5. And then those cancel out, and that leaves me with x by itself. Okay. And so that's how we find those pieces. All right. Now let's talk about the domain for these. Okay. Now the domain comes from two different parts. If we go back and look at our definition, the domain says that x must be in the domain of the second one, or for this one, our g. So x must be in g, and then g of x must be in f. Okay. So we need to look for those pieces. So the first thing that we need to do is we're going to start right here, what we're plugging in, and we want to look at that domain. So the domain for that, well, it's a quadratic, x squared minus 5. There are no problems with x squared minus 5. And so this domain is all real numbers. Okay. So we don't have a problem there. Then we need to look at here. So absolute value of x. So that's our final answer. Do we have a domain issue with this one? So here, the domain is all real numbers for that piece. Now, since both of these are all real numbers, that means the domain of f of g of x is all real numbers. Okay, we're looking for the most restrictive, and these two are the same exact same thing. We don't have any problems with them, so there's not an issue here. Okay. All right, now how about g of f? So we go here, our function that we're plugging in with those. We look there. Is there an issue? Well, that's a square root. There are issues for square roots. So that means for our domain, x plus 5 must be greater than or equal to 0. Okay, because we can't have negatives under there, right? And so that means x must be greater than or equal to -5. Okay. Now for down here, I'm going to do it a little higher. Its domain is all real numbers because it's just x. But again, we need to be the most restrictive for those. So all real numbers isn't our final answer, even though that goes with the final part of f of g. It's the most restrictive out of these two things. And so our domain for g of f of x is going to be x is greater than or equal to -5. Or we can write that as -5 to infinity, like so, like we talked about before for those pieces. Okay, so that's what you're going to look at on those. You're going to see, hey, what are they? Or if they're both all real numbers, great. That means my domain is all real numbers. But if they're not both the same, then we're going to pick the most restrictive out of those pieces. Okay. So we're going to need some of that in the future. We're going to talk about composition a little bit more. So please be aware of those pieces.